Welcome back. I wanted to show you one more factoring method, and then we'll be good to go for section 1.5. So this is the second part of our 1.5 video. Here I have a hard polynomial. I'm going to make a different easy polynomial out of it. So this is a different polynomial. It doesn't have the same value. If I plug in x, I get a different answer. But what I'm going to do is take this 5 and slide it to the end and multiply. So it's going to make x squared plus 7x minus 30. I multiplied the 5 into the third term. So this is a different polynomial. Like if I plug in 1, up top I get 12, or up top, if I plug in 1 for x, it has a value of 6. But down below, if I plug in 1 for x, it has a value of negative 22. So these are two different expressions with two different values. Don't think that they're the same expression, but the second one's easy to factor, and knowing the factors tells me something. So I factor this, and this is easy. It's x plus 10 times x minus 3. What I'm going to do then is divide by the thing that I slided. So this 5 that I slid, this is the second part. It's the and divide. And so I get x plus 2 times x minus 3/5. And then optionally, we gotta do one more slide. Slide this 5 back up and call this x plus 2 times 5x minus 3. And as if by magic, when I FOIL this guy, first is 5x squared. Outside is minus 3x, inside is plus 10x, and last is negative 6. And 10x minus 3x really is 7x. So when you slide, you get an easier polynomial to factor. You do your factoring, and then you divide. Slide one more time, and you have a factorization for the hard polynomial. Real cool. That's going to save us a ton of time. So let's practice this a few times, eh? Let's say I had 2x squared plus 9x plus 9. I'm going to slide. Different polynomial, easy one, x squared plus 9x plus 18. 18 is 6 times 3. This is x plus 6 times x plus 3. Divide. This is x plus 3 times, well, I'm not going to write x plus 3 halves. I'm going to write 2x plus 3. I'm going to slide that back out front. Check that by FOILing. You really do get 2x squared plus 9x plus 9. How about, oh, this one's wacky. 6x squared plus 41x plus 63. I'm being mean here. We're going to slide that 6 on down. Make a new polynomial, x squared plus 41x plus a big old number, 378. Well, crap. What are some factors of 378? Well, I know from a second ago that it's 6 times 63. I know that that's 7 times 9. I know that this is 2 times 3, and that's 3 times 3. So 378 is 2 times 3 cubed times 7. Now we can start listing factors. 14 and 9, not big enough. 6 and 63, no, we already did that. That doesn't work. 3 times 7, 21, and then 18. Oh, we're close. We're close. Those almost add up to 41. Not quite, but 21 and 18 are close to working. 3 cubed is 27. 2 times 7 is 14. So 27 times 14. Those add up to 41. So we've got, we're in working order. This is x plus 21 times, not 21. X plus 27 times x plus 14. That's the factorization of the, I'm going to put easy in quotes here. It's certainly easier than, than this hard. I'm going to underline hard here. This is hard as heck. This one is only easy in the sense that it's a lot easier than the hard one. We factored our, quote, easy, unquote, polynomial, and now we divide. Check out this. This is how this works in this complicated case. 27 over 6 reduces to 9/2, and 14 over 6 reduces to 7/3, yeah? You want to reduce them as much as possible, and then we're going to slide those denominators right back up, like so. So my final answer is going to be 2x plus 9 and 3x plus 7. Yeah. We'd better check our work. Let's FOIL. First, 6x squared. Outside, 14x. Inside, 27x. Last, 63. What do you know? We got it. Because 14 plus 7 is 41. We got it. We did it. Not bad. Not bad at all. Let's do one more. 6x squared plus 5x minus 4. We're going to slide that and make a new polynomial, not equal to the old one, but easier to factor. I think we've already done this one. This was x plus 8 times x minus 3. Now we divide. Oh, this is another, yeah. When we divide by 6, we get x plus 4/3 and x minus 1/2. I'm going to punch that back up and make 3x plus 4 and 2x minus 1. Foil those on your own. It really does work, though. We get a 8x here and a negative 3x here. It fixes it right up. So that's slide and divide. It's real handy. Let's do one more big dumb monster example before we go. Let's say I ask you to factor, I don't know, how about 60n cubed minus 190n squared minus 110n. Yeah, big ol' monster. What is this, professor? This is a cubic. We're going to get this down to something we can slide and divide in just a second. How are we going to do that? First thing you always try is a GCF. Now, every one of these terms has an n in there. Also, every one of the coefficients ends in 0. So I can pull a 10n out and get left with 6n squared minus 19n minus 11. It's not perfect, but it's better than what we had before. Let's see what else we can do. I guess I'll slide and divide. I'm left with 10n times, oh, you know what? I'm going to draw this in blue. This is a different polynomial entirely, so I'm just going to draw this in blue. Check this out. This is important. My new polynomial is n squared minus 19n minus 66. Mercifully, there's only a few coefficient pairs for 66. It's either 1 and 66. No, those aren't 19 apart. How about 2 and 33? Not even. 3 and 22. Bingo, bingo. So this polynomial factors as n, what do I want? Minus 22 and plus 3, yeah? Because those add up to negative 19, and they multiply to negative 66. So those are the factors of the easy poly. We'll put the 6 back in, and we get n minus 11/3 and n plus 1/2. We'll slide those back up front and write them as 3n minus 11 and 2n plus 1. We're almost done. The original polynomial, the hard guy here, was multiplied by its friend 10n, so its factors are still multiplied by 10n. Put that 10n back in, and this is our final answer. 60n cubed minus 190n squared minus 110n. Foil it out and you'll see that I'm right. It is 10n times 3n minus 11 times 2n plus 1. And that is factoring polynomials for you. You can close the video now if that's all you want. Otherwise, real quick, I think it's interesting to see why it is that slide and divide actually works. Matter of fact, let me make a new video with that. So the second part, just if you want to see the magic behind the curtain. You don't need it. It's optional.